Okay, so let us apply Kirchhoff's laws to solve this problem. We are supposed to determine the value of current flowing through each resistor. So let us start by looking at the power sources. The 10 voltage supply current will flow in that direction. Let us call that current I1. The 20 voltage battery, its current will flow in that direction. Let us call it I2. So I2 flows through 20 ohm resistor and I1 flows through 10 ohm resistor. Then they join here at that point to form a new current I3. So that means if we look at the junction rule, current at the junction, I1 and I2 are entering the junction at A, while I3 is leaving the junction. So the algebraic sum of current at the junction should be equal to 0, i.e. I1 plus I2 should be equal to I3. That is equation 1. Now the second one should be the loop rule. So for the loop rule, that means we have to use loops in order to also look at ways on how we can solve this problem. We can draw a loop here and call it loop 1, and another loop here and call it loop 2. So loop 1, we can give it direction. Let it be like this. Then loop 2, we can also give it direction. We give it direction. You give directions the way you want, as long as you maintain the direction, you maintain the order of the arrows. Maybe we can also, let us label these resistors such that we can call this one R1 since I1 is passing through R1, R2 since I2 is passing through R2, and the 40 BR3. Anyway, I prefer using squared or rectangular loops for simplicity, like this. So this is my loop 1, this is my loop 2. So for loop 1, when we look at the loop rule, the total EMF should be equal to the total potential drops. For loop 1, the total EMF is 10 voltage. There is no another voltage in loop 1, which should be equal to the total potential drops. Now 10 is positive because the EMF, the direction of the EMF is the same as the direction of the loop at this point, if you look at that. Then current I1 is in this direction, and the loop is also in the same direction, meaning we shall have I1 R1. I1 is positive since it's in the same direction as the loop. Then plus, when we look at current passing through R3, current is downwards, and even the loop is also downwards, same direction, meaning I3 is also positive. So it is I3 R3. So that is our second equation. We can substitute for R1 as 10, I1 plus R3 as 40, I3. So this is the second equation. Then the third equation should be for loop 2. The other one was loop 1. For loop 2, the direction of the 20 ohm voltage is positive since EMF is upwards, and even the loop is also upwards. So 20 should be equal to, current here is in that direction, and even the loop is also in the same direction. So we shall have I2 R2 now plus down here current I3 for loop 2, it has I3 downwards, and even the loop is also downwards. So we have I3 R3. So we shall just substitute for R2 as 20, I2 plus R3 as 40, I3. So we have those three equations. The first one was I1 plus I2 being equal to I3. Then 10 is equal to 10 I1 plus 40 I3. Then the last one was 20 is equal to 20 I2 plus 40 I3. So when you solve upon solving all of these equations, you'll have I1 as negative 1 out of 7 amperes, I2 as 3 out of 7 amperes, and I3 as 2 out of 7 amperes. 2 out of 7 amperes. 2 out of 7 amperes. 2 out of 7 amperes.